Welcome to Intro to Stat, Unit 2, Lesson 1. Unit 2 is all about averages and variation. In Lesson 2.1, our lesson is going to have an objective of being able to apply measures of central tendency to data sets. We want to know what the typical value is, what the middle of the distribution is. And there's three common measures of central tendency: the mode, the median, and the mean. The mode is the value that occurs most frequently in a data set. Mode and most frequently sound similar. So if we want to find the mode of the data set that's given to us, we've got 6, 7, 2, 3, 4, 6, 2, 6. We just want to know which value occurs most often. So the mode is 6 because it occurs 3 times and no other value occurs 3 or more times. All right, we're going to do the same thing for 6, 7, 2, 3, 4, 5, 9, and 8. Everybody occurs once, each little individual that's there, so there is no mode for this data. Another measure of central tendency is the median, and that's the central value of an ordered distribution. So you just list everything in order and find the one that's in the middle. So like the median in a road is that little like raised area in the middle. The median is the middle value. So to find the median of raw data, you're going to order the data from smallest to largest. For an odd number of values, pick the middle value. Or for an even number of values, what you're going to find is that when you count into the middle, you have 2 middle values. So you just average the middle 2 values. Just add them up and divide by 2. All right, so we're going to find the median, and our data values are 5, 2, 7, 1, 4, 3, 2. So we need to put them in order. So we've got 1, 2, 2, 3, 4, 5, 7. And then we're just going to go into the middle. Okay, and so you would count in 1, 2, 3, and then the fourth value there. And then from the upper end, 1, 2, 3, and the fourth value there. They both land on 3. And so the median is 3. It's the fourth value, but the actual value of that fourth value is 30. So the median of the set is 30. All right, so this time we've got 31, 57, 12, 22, 43, 50. We're going to rearrange. Now, if we count into the middle, okay, here's my first small value, my second small value, third small value, then 4 small values. So then let's go from the biggest value, the next, third, next, fourth. Okay, we've got 2 middle values, 31 and 43 if you're counting in from either side. So we're going to take the average of 31 and 43. Okay, so in between those two, the median is the average of the middle 2 values. And so 31 plus 43 over 2 gives us 74 over 2, which is 37. For a large data set, if you want to figure out what the position in the middle value is, we just kind of count it in. But sometimes it's really hard to do if you had like 157 values. You take the number of values, so like I said, 157, and then you add 1, and then divide by 2, and that's going to tell you the position of the middle value. And then you would just count in that many times and find your middle value. All right. So the last one we need to talk about is the mean. That's what you typically think of as an average. All 3 of these can be considered averages, but the mean is the typical average that uses the exact value of each entry and is sometimes called the arithmetic mean. And that's where you add everything up and then divide by the number of items. So you sum all the entries and then divide by the number of entries. It's just like how if I want to find your test average, I add up all the test grades and divide by the number of tests. So the sum of all the entries divided by the number of entries. So if I find the mean of 6, 7, 2, 3, 4, 5, 2, 8, I just add all those values together. There's 1, 2, 3, 4, 5, 6, 7, 8 values. So I divide by 8. And so I get 4.625. And typically we round means to one more decimal place than what the data were actually recorded in. So since we've got 6 and 7, we've got whole numbers, we go to the nearest tenth. Okay. One thing that you need to be familiar with is sigma notation. It's going to make it a lot easier for us to use some formulas that we need to use. This right here, this little symbol, is the Greek letter. It's the capital sigma. There's lowercase sigma, which can mean another value we may look at later. But this big sigma means the sum of the following. So you add whatever it tells you to add after that. So notations for mean, we've got the sample mean, which is x bar, and then we have the population mean, which is mu, another Greek letter. Okay, it looks kind of like a combination of an M and a U. Okay, it looks almost like a weird M there, and it looks like a U, and it's called mu. All right, the number of entries in a set of data is represented by n. If we're talking about a sample, a subset of a whole population, if it's the actual whole population itself, and you know how many members of the population you have, you use capital N. All right, so the formula for the sample mean is x bar, and that's how that's referred to, equals the sum of all the x values, all the actual entries, divided by n, little n, the number of entries in that sample. For the population mean, here we've got our mu again, equals sigma, so the sum of all the x values in the whole population, divided by capital N, the number of observations or entries in the whole population. Okay, one thing we need to talk about, because people have to choose between whether they're going to use median or mean, is whether or not a measure is resistant. A resistant measure is a measure that is not influenced by extremely high or low data values. You just take the middle value. If the biggest value is huge, if the biggest value is not that much bigger than the rest of the values, it doesn't matter, because you're just going with the middle for the median. For the mean, though, you take into account all the values. So which is less resistant, mean or median? The mean is less resistant. It can be made arbitrarily large by increasing the size of one value. It can also be made arbitrarily small by decreasing the size of one value. Okay. All right. Next time we will look at lesson 2.2. You're ready to do the problem to try on your own, so go ahead and do that. Thank you for taking great notes and listening to the video. I will see you in class. I hope you have a great day.